Here we go. So, hi everyone. Hi to all the participants that are listening to us in Gather Town. And hi to everyone who's here from each association in the Public Roundtable. And welcome to the Public Roundtable on AI and the environment here at CAIP'21. So before I present each association, I just wanted to say just a few words about this Public Roundtable. So that everyone is clear about what to expect, what's going to follow, and then I'm going to introduce each association. So first of all, what to expect from this roundtable. First, I will briefly introduce each association. Each association will have around 5 minutes to present their work within the sphere of AI and the environment. And then we will open the floor for questions from the moderator, but especially from the audience as well. What is the aim behind this roundtable? The aim between associations is the one to share knowledge, but also challenges and opportunities in the space of AI and the environment, and also to share knowledge for potential collaborations. And the aim, let's say, between associations and the public is for associations to get closer to the public needs, but also questions, and for the public also to get to know what the several and multiple associations do, but also how to become more active in the sphere of AI and the environment if they wish. So this is what to expect. This is what's the aim. Now let me introduce you to the associations present here today. I'm just going to present the associations, but then I'm very happy to leave the floor to the various representatives to introduce themselves and their work. So we have Climate Change AI here today, represented by Hari. Welcome, Hari. Climate Change AI is a global initiative to catalyze impactful work at the intersection of climate change and machine learning. Apart from Climate Change AI, we also have the Italian Association for Artificial Intelligence, represented by Emanuela here today. This is a no-profit scientific association with the aim of promoting research and dissemination of the techniques of AI. The association aims to increase knowledge of AI, encourage its teaching, and promote theoretical and operational research in the field through seminars and targeted initiatives, and also sponsorship of events. And then we have Mila, represented by Victor here today. Mila is a community of more than 500 researchers specializing in machine learning and dedicated to scientific excellence and innovation. Their mission is to be a global pole for scientific advances that inspires innovation and the development of AI for the benefit of all. And then we have Pi School. We saw the guys of Pi School this morning as well. We still have Sébastien, we have Cristiano here as well. Basically, Pi School is the gathering point of game changers in the field of technology, creativity, and entrepreneurship. It is a leading international institution with headquarters in Rome, inside the startup community of Pi Campus. The school promotes the meeting of the latest state-of-the-art technology with the most innovative ideas. And finally, we have ARCO. ARCO, represented by Priscilla, hi Priscilla, is Africa's leading hair quality monitoring, research, and analytics network. They use low-cost technologies and AI to close the gaps in air quality data across the continent. They invite people to work with them and to find data-driven solutions to air quality challenges. So here is all the associations of today. Now I want to leave the floor to the representatives of each association. I would invite you and welcome you to start in the same order in which I've presented you. So I would like to start from Climate Change AI with Hari. And I welcome each of you to present as I anticipated in your preferred format. You can share your screen with slides and go ahead if that's the case. Otherwise, you can also just talk to us and share your knowledge. So Hari, the floor to you.
Okay, let me try to share my screen.
Sure.
Can you see my screen?
Yeah, working perfectly.
Hi, I'm Hari Prasanna Das. I'm a PhD student at University of California, Berkeley, and I work on smart building and machine learning challenges. And I'm part of the organization called Climate Change AI that I'm representing today. Great, so let's get started. So climate change, as everyone knows, is a increasingly important problem, and it is having to have increasingly severe effects like storms, droughts, fires, flooding, and extreme heat conditions. And it is having uneven impacts, and the whole world is affected by it. And we have the goal to have net zero greenhouse gas emissions by 2050. And despite all those challenges and despite all those resolutions that we plan to obey by, we have our emissions still increasing each year. So in the space of climate change, the mitigation and adaptation approaches are needed, very important at this point of time. And we believe that machine learning is a powerful tool in this space. So let's just give you a brief explanation about what machine learning is. So machine learning is a group of techniques that automatically extract patterns from a large amounts of data. And it has some strengths like it can scale human insight, it can optimize very complex systems, and it can also generate new data that we can use further to make systems more robust, and it can integrate with other methods. And it also has limitations as with everything, and the limitations are garbage in, garbage out. If you feed data that is having more that has different biases or different issues, the output or the insights that we'll get from the machine learning algorithm will change accordingly. It inherits biases in data or design or the use. So it depends on the user or the data. If it has some bias, then the outcome will also be biased. Then it also assumes that patterns are persistent, which might not be correct all the time. And it tries to find correlation, not causation. So with that strength and limitations of machine learning and the increasing threat of climate change, we came with a paper called Tackling Climate Change with Machine Learning around 2 years back, and different experts from different universities came together to write this paper, which kind of became basis of the formation of climate change AI. And so let me introduce what climate change AI is. So climate change AI is an initiative to facilitate work in climate change and machine learning. And we try to catalyze impactful work at the intersection of climate change and machine learning. Let me cover some of the different initiatives that we have. So in general, all the resources that I'm going to mention today will be available at our website, www.climatechange.ai. And in summary, we organize virtual happy hours, newsletters, tutorials, Wikipedia, and a lot of other events like webinars. So I'll just go through them one by one, telling more about each. And starting with this tool that we provide, which is called papers, which is used to search the different papers that we have had in the workshops that we have organized. And this is one of the tools where you can search different uh, papers and manuscripts or different proposals that have appeared in the workshops that we have organized in past. So you can do that by going to climate change AI/papers. We also have this platform where you can connect with the whole community and can find collaborators and like-minded people who want to share the research with you. That is at community.climatechange.ai. We have a directory where you can also find different peoples with their bio and about if they're looking for some expertise or if they're offering some expertise. So that is directory.climatechange.ai. We share a monthly newsletter that is getting quite famous day to day, and we encourage everyone to sign up for it. And we try to feature a different call for submissions for at workshops, conferences. We feature fundings, we feature projects and courses, readings, and we feature a vast amount of jobs that are related to climate change and AI space. We have happy hours. I'm sorry, the the date on the top will be changed. And so happy hours is kind of a space where you can come and in an informal setting can meet other people that are also working in the space and also share the same concern with you. So you can collaborate with them or find different solutions that can eventually lead to mitigation or adaptation of climate change using machine learning or some other means. This is an upcoming CCAI event that we're having in December. So this is a workshop at the conference on neural information processing systems. For those of you who don't know about NeurIPS is a premier conference focused on machine learning and its applications. So we are having a workshop there called Tackling Climate Change with Machine Learning. So to stress here, you don't need a paper to attend this workshop. You can attend this workshop virtually, even if you don't have a paper. More information on this can be in our page under events/NeurIPS'21. Great. Without taking much time, I'll conclude about climate change AI here, and all of the information are at climatechange.ai, and our Twitter handle is climate change AI. Thank you.
Thank you so much, Hari. Thank you for sharing the work of Climate Change AI. Questions can be asked at the end when we open the floor for questions, if you're okay with that. Now I invite Emanuela from the Italian Association of AI to share her screen.
Hi, everybody. I try to share my screen. Let's see if it's working. Can you see it?
Yeah, that's perfect. Working.
Okay. Sorry, I just don't know how to leave this. Okay, perfect. Okay, hi, and thank you for inviting me. I will also put a timer so I know where to stop. Okay, so Marta already presented the Italian Association for Artificial Intelligence. I just wanted to add a few things, a few activities that we are developing as well. So we have 12 working groups on all the areas of AI. So machine learning, of course, and deep learning is one of the most, not the most important, is one important group, but we also have optimization, planning, argumentation, robotics, natural language processing, and so on. Then we have an international journal, and we publish twice a year, and it's quite a prestigious journal. We have an annual scientific conference. The next one will take place at the beginning of December. This year, of course, it will be online. We have an event for companies. This is really to bring together the research with the academy. So really to realize also the one that it's called the European strategy from lab to market and from academy to industry. And then we have the next event actually is taking place next week on the 23rd of November. And we organize lots of social impact activities. For instance, we just published this year a comics on science, and it's a very cute one. It's also available in English on our website, and it's a comics about AI. And it's funny because there is this robot going to the psychologist because he feels very sad and very depressed because he cannot help a human being. So it's very interesting also for AI for people. So today I wanted to talk to you about this study that we developed with the Italian Association for Artificial Intelligence. And this study is how to use AI for reaching the SDGs, AI for the sustainable development. What is important, which is one of the main findings of this study, is that basically, we cannot use AI only for tackling climate changes. We always have to have a sort of coordinated and systematic vision, because if, for instance, we focus on reaching the SDG 13, that is climate action, then maybe we have a negative impact on another SDG, maybe on the second one or the third one. So we always have to keep the balance, and it is very important to have a coordinated and systemic vision. And the other point that it was already also introduced by Hari, he talked about the strengths and limits of machine learning. So what we did is that for every application of AI technologies, we analyze the opportunities, great opportunities, of course, but also the risk related and how to manage these risks. And the other important thing that we did, three considerations that we took into consideration, we took into account when we did this study, is that first of all, especially in AI, first thing, we need to set the goal. And the goal for us are the SDGs of the Agenda 2030 of the United Nations. The second thing is that it is very important when you use AI technologies to define very well the context. And in defining the context, we identified 3 main points that have to be considered. The first one is that we need to shift from a human-centric to a planet-centric approach, which is quite weird, I know, because for AI for people is really human-centric, but this is very important. The second is to identify which one are the scarce resources today. And the third part is to identify the right index to measure if you reach the goal. I will spend very few time on this. So the first one, why do we need to move from a human-centric to a planet-centric approach? Basically, because human beings, are just one of the elements of the ecosystem, and so we really have to, to move, to realize this paradigm shift, and really to put at the center of all our policy the planet, and not only human being. And if we put the planet, then we will also reach the well-being of human beings. The second point is that, the traditional economy usually identified as scarce resources, the labor and the capital, but it considers natural resources like if they were unlimited. And this is very important because we need to move from a cowboy economy where resources are unlimited, basically like prairies, and to a spaceship economy. And this is also the theory of Kenneth Boulding. And he said we have to consider basically that spaceship planet Earth, and that we have to consider the natural resources are limited and they must be reused in a circular economy approach. And the last part is that, so if we define that the goal is the SDGs, so we have to use this planet-centric approach, basically the index that are currently used globally to measure, the profit basically today, they're not, they're very useful, but they're not enough. So we need to identify new index. And what we propose, for instance, in Italy, we have this new index called BASE, which is the equal and sustainable well-being. And there is also an international movement called the Behind GDP, and they are identifying the new elements that need to be measured. Okay, I finished my time, so I take just half a minute. Just to conclude, this is just to show you what we did in this study that unfortunately is available at the moment only Italian, but we are about to translate it into English. For every SDGs, so for the poverty, we identified what can we do today with AI and which one are the opportunities, which one are the risks, and which one are the best practice that are already developed with AI systems around the world. And we did it, of course, also for climate action, for SDG 13. And I think that one very important point was already introduced, of course, by Harry, so that we can develop models to predict the impact of the climate policies. The risk, of course, we have to consider also the carbon footprint of AI technologies. And for the best practice, a very interesting project is the one developed by European Commission. It's called Destination Earth, and is a digital twin of planet Earth. So I don't take any other time because I know that the other presentation will be also very interesting, and then I'm available for questions. Thank you. I just try to stop share. Okay, thank you.
Thank you so much, Manuela. You're just perfectly on time. And thank you for the great presentation. Now I think next up is Victor from Mila. Victor, please go ahead if you'd like to share your screen or start your talk. Cool, I can see it.
All right. Hi, everyone. So I'm Victor. I'm a PhD student at Mila in Montreal. So I'm supervised by Professor Yoshua Bengio. And this, I'm going to present to you today a very specific project. This is what I've been working on for 2.5 years. It's a website called This Climate Does Not Exist that has been developed with, them, Yoshua, Sasha, and a lot of other people here. And the goal of this project is really to use some of the tools we have developed in AI, namely GANs, which were developed at Mila, actually, to generate new images, and how can that help try and fight climate change. And the approach we have developed is to actually leverage empathy and make an interactive website where people can just go enter an address, we fetch a Google Street View image of that location, and then we can transform it with one of three, well, actually the three, but not at the same time. You'll see an example. One of three events, namely floods, wildfires, and smog. And so what the algorithm does is it takes an input image, it processes that image, and it generates a flood or a wildfire event. So this is inspired by the wildfires in California in 2019, I believe. And we thought, well, this is maybe what it looks like if there's a wildfire close to your city. It would be weird to just put flames on buildings, but this is what it actually looks like. And this is feedback we've received from people who have been in those areas, including in British Columbia, here in Canada, and so on. And smog is a kind of air pollution that is expected to become worse and worse with climate change. And so, to give you an example of what it looks like, this is where I live in Canada. And so the algorithm is able to detect the perspective, objects, and paint water contextually. You can also see, for example, here in the smog and the wildfire. And if you're interested in looking at how it works, we have this animation in the About section of the website that explains how the images are processed and what's the algorithmic path from an input to an output. And so the goal here is really to have an interactive website where people can try and put themselves in other people's shoes. Maybe you live on top of a hill and you'll never have a flood, but your actions are still going to impact other people, and the actions of your government and the companies you buy from are going to impact everyone, both in the future, but even right now, we already see the consequences of climate change. So it's not only about what is going to happen to you, it's about what happens to everyone because of everyone. And this is, I mean, at the center of the problem of climate change. But once you've gone through this experience, I mean, we're not going to let you down there. We have a very complete what now section. Now that you've maybe, hopefully, maybe crossed the line from knowing to doing, and you're willing to do something now, maybe a little more than you were. There are a few things that you can do here, and I'm not going to get into it, but there's quite a list: individual actions, collective actions, learning more about specific events, and so on. And I'm going to take just a minute to talk about another project that I've been working on, which is about quantifying the carbon emissions of machine learning. So there's this calculator where you can input the kind of GPU and or CPU that you've used, the amount of time, where you've run this for. Maybe it was in Asia East 1, the region for Google Cloud, but it could also be a private infrastructure. You just have to input the carbon efficiency of the grid you plugged into, and that's going to compute. It's just a bunch of multiplications, nothing very fancy, but the easier, the more likely people are to use it. And going from that post hoc measurement, which is not actually measurements, but really an estimation, we're also working on Code Carbon. Code Carbon, yeah. It's a Python package to track the carbon emissions, so the energy, and then you multiply that by the carbon efficiency of the grid of whatever you're doing. It's most precise with GPUs, and if you want to get into details, we might have a time for discussion there. So I'm going to stop here. I don't know if I was too long, Mara. If I was, sorry.
No, you were perfect. Just on time as well. Thank you so much. Very interesting project. Really, thank you for sharing. And I think now we have next up PySchool. So guys, you go ahead. I'll leave the floor to you.
Okay. Hi, thanks Marta. Thanks again for the intro. So let me show you what's going on our side. Okay, I'm going to speak briefly about PyCampus and then about PySchool to tell you what we're doing. Is this sharing? Yep. Okay, so the PyCampus is a venture capital fund, and we invest in applied AI startups mainly. We've done 52 investments, and I'm going to speak about a few of them. We've done them in the last 5 years that's the existence of the fund, and we invest at seed stage. So it's pretty small investments, 50,000 to 500,000 euros. We're based in Rome, and so that explains why half of our investments are in Italy, but we also invest outside Italy, especially we co-invest with Y Combinator. So a number of the startups that I'll speak about are co-investments with that we took from Y Combinator. And you can see here the logos, I guess, the numbers for all those companies we invested in, 52 to date. And I'm just going to pick out a few to tell you about the sort of work that's possible to do in sort of conjugating work in AI with an impact on sustainability. So I'll pick out one here. This is Earth AI. So Earth AI is a mining firm, and what they're developing is a system to do more efficient ore mining and metals mining. And so instead of digging open essentially very large very large mines, very large fields in which mining is carried out, what they aim to do is to do essentially the equivalent of precision medicine, but in the mining field. So they aim to be able to predict the presence of ores and minerals and metals with very high precision based on, methods and sensors that are generally available, stuff like satellite imagery, and then a couple of ground samples and stuff like that. In comparison to the traditional mining technologies, they're less destructive. They claim they're 70% more efficient in predicting the presence of minerals. So that means that in all those cases where the traditional methods which have gotten the prediction wrong, you don't need to dig open the ground and start doing some polluting activities essentially in order to ascertain the presence of minerals. So that's Earth AI. And another one is Space Ride. So Space Ride is tackling the problem of essentially putting stuff into orbit around the Earth. The traditional way to do that is to put stuff, essentially satellites and cargo, onto a rocket and then lift it into orbit and then release it there. So what they're doing is they're trying to develop a system. This is a Y Combinator co-investment, by the way. They are developing a balloon and rocket system where the balloon does the largest part of the lifting. And so this is this represents a very large reduction in the fuel consumption to lift cargo up into space. And then the cargo is released with a rocket attached that does essentially, it's a bit like last mile food delivery into space. And so the point here is that instead of using a rocket system, many parts of which are just can be used only once. Instead, their rocket and balloon system can be reused, and instead of pumping fuel, like burning fuel and lifting stuff that way into space, they just use hot air and helium balloons to lift things, just thanks to gravity and the properties of hot air balloons. So that's what Space Ride does. Turan Space is another space-related startup, and what they do is they tackle the problem of maintenance and debris collection in space. So in the next 5 years, we know that about 15,000 microsatellites will be sent into space, and that represents a ton of potential garbage once they're at the end of their lifetime. And so what Turan is working on is a way to collect the bits and pieces that detach during the lifetime, that detach from a satellite, collect that, and also essentially increase the duration of the lifetime of satellites in order to keep them in space for a longer time and avoid having to sort of renew entire fleets too often. Okay, so this is a problem which is only nascent. It's bad enough these days. But for many people, it's not on the radar yet. But it's certainly becoming a very crucial problem in the years to come, with plans of deploying microsatellite fleets. And here I want to stop speaking about what PyCampus companies do and speak more specifically about what PySchool does. So PySchool is one of the companies within PyCampus. There's one program that I wanted to speak about, which is the School of AI, that we're running several times a year. It's an 8 weeks program in which we invite people with a background in AI to work on interesting industry problems, which are given to us by, well, different industry players. And then I'm going to pick out a couple of these projects which are related to our topic today. So we're selecting people based on merit, and the way that fellows, we call them fellows on the program, that the learning happens is people come in with a background in AI, and it might be people with a PhD or people with a master's degree, some people further down in their career already. And what we do is we pair them with an industry that's got a business pain that we have found an AI approach, or essentially it's a machine learning based approach, to solve. And then we set this up, we prepare the projects for the people so that when they come in, many of the business issues and sort of data preparation issues have already been solved for them. Sit down and work, I would say, on the interesting part for 8 weeks, receive some mentoring from ourselves at PySchool, and then also from mentors that we have that help us. And we hand over a prototype solution to our stakeholders here, to the industries. So these are all real world projects, and we tend to take the algorithms we implement from the very recent state of the art, so from archive publications, usually, and customize them to the problem that we're working on. So I'll give you a couple of examples here. A couple of mentors here that have helped us throughout the, we're starting the 9th session in a couple of days now. We've done 72 projects yet, and we're preparing a couple new ones for this 9th session. We've trained 150 people. We're advised by these people, Alex, Hassan, and Marcello, who are all veterans of AI and who are essentially helping us to keep the program at a really high level. And then mentors are people from our professional PyCampus network who come in and help on the vertical that they're specialized in. A couple of examples from our challenge portfolio. So I'm going to skip over these ones, but you see the idea, I guess. They're from different industries, different fields of AI. We're just going to go straight to a slide I've prepared on the, it might be on time already.
Yeah, it's like quite over time.
Oh my goodness.
Yeah.
Can I just list these and I'm done?
Yeah, just
my last slide. Thanks, Mark.
Yeah.
And apologies to everyone. And these are projects we can speak about later on. So we did projects with NL and NG, electricity utility companies, electricity providers, the European Space Agency, and other aerospace and satellite imagery companies, EGOS and MEO, with Octo Telematics on fuel for cars, fuel level prediction for cars. We're working with International Fund for Agricultural Development to essentially scope out some projects. And just this morning, my colleagues Cristiano and Francisco reported about a project we've been doing with the EU John Research Center on NLP for industrial pollution control. Thanks.
Okay, perfect. Thank you, Sébastien. Thank you for running through the last slide. Now we have Priscilla from ERCO. Priscilla, if you want to go ahead.
Yes, thank you. Good evening, everyone. Just a few seconds, I share my screen. I hope that's visible. Yes, so my name is Priscilla and I work with ERCO as a data scientist. Well, AirCo is an air pollution monitoring project that is based at Makerere University and mainly funded by Google. So why do we care about air quality? I'm just going to give you a bit of background as to why we do this and then how AI comes in. So according to the World Health Organization, air pollution is the world's largest single environmental risk. And about 7 million people die every single year from causes that are related to air pollution. So as you can see, 7 million is quite a big number every year. So this is a problem that actually needs our urgent attention. It's something we really need to manage. However, we cannot manage what we cannot measure. And the main challenge we've had in Africa is the scarcity of air pollution data, not because people are not interested in monitoring, but there are several challenges that are associated with monitoring air pollution, including the cost of the equipment, the reference monitor, which is like the traditional monitoring. The traditional monitors cost like thousands of dollars, something we cannot afford. And yet with air pollution, you may need to have, we need to optimize the spatial coverage in order to cover as much area as possible. So the map on the right shows air quality monitoring stations around the world. So each rectangle is a monitoring station. And as you can see, this was taken in 2019. In Africa, the stations were very, very few. And in Uganda at the time, we only had one, which belonged to the US Embassy. So as AirCo, we develop we use low-cost technologies and artificial intelligence to fill the data gaps. So we develop low-cost air quality monitors that work for our contexts. Like they are low cost, they are weatherproof, and they are portable. So basically things that work for us. And then we also use artificial intelligence to power up the sensors and also fill in places where maybe the monitors cannot be placed. One of the use cases of artificial intelligence is sensor placement optimization. So one of the main things we need to do is to reduce the cost of monitoring air pollution. So much as these sensors are low cost, they are not very cheap either. So we use AI to determine, say, if I have 25 sensors and I need to place them, say, in a city like Kampala, what would be where exactly can I put these 25 sensors in order to get the representative state of air quality in that area that I am interested in? So that is one of the uses. The second use case of artificial intelligence is improving the accuracy of data from our low-cost monitors. Well, one of the biggest challenges with the low-cost monitors is that the accuracy may degrade, especially as the sensors start to age. So how can we resolve this? How can we work? So the solution is using AI. So what we do, as you can see from the picture at the top, we collocate our low-cost monitors. They may not be very visible in the image, but these are the arrow points to the low-cost monitors with the reference monitors. So these two white, the huge ones, are reference monitors, such that they are sampling the same air. And then we use machine learning to build the relationship between data from the two devices. Then this relationship is then used to translate data from other low-cost monitors across our monitoring network into reference grade equivalent. So maybe just to give you an idea of how efficient the model, the model is, the graph on the bottom right, it compares the calibrated data from the low-cost monitor in red, and then the blue line shows the data from our reference monitors. So as you can see, the accuracy of the models is quite good. So it's actually, we use artificial intelligence to help us improve the accuracy of the data. The third use case is air quality prediction. So again, for the sake of reducing costs and other challenges, we may not be able to have monitors in each and to cover each and every kilometer that you may be interested in. So how do we work around that? We place after optimizing the placement of the sensors, then we can use the data from the sensors that we have as inputs into our model, plus other factors that we know affect the pollution of an area, such as population density, human activities, distance from road. So all these are used as inputs into our model, and then they help us predict the air quality in locations where we do not have physical sensors. And then the final use case that I'll talk about today, of course, there are others, but they are not yet, we are still building those models, so I'll not really talk about much about those today. So the final use case for today will be the air quality forecasting. So it basically tells you what the air quality will be in future. So far, at the moment, we forecast air quality over the next 24 hours. So the graph below shows a sample of air quality forecast. This was air quality forecast from today at 12 p.m. to tomorrow 12 p.m. So someone can use this information to make individual decisions that help them minimize their exposure to air pollution. Yes. Those are the use cases that I'll talk about today. Thank you for listening.
Thank you so much for your presentation, Priscilla, as well. So by now, I think all of you have gone and had a chance to present what you are working on or what your association is working on. And now we come to the part of the roundtable where we open the floor for questions. I would have started with one, but we had quite some questions from the public. So I thought about starting instead from the public, and I copy-pasted here the questions that I received from GatherTown. Now you will see some questions are very general, some other questions instead are more specific to certain projects or certain points that were raised by a specific speaker or association. I would start with a very general one. Perhaps the way we can go about it is we don't have to respect necessarily the rigid order in which we have started. So if anyone feels like jumping in, do jump in, especially if you feel like the question is specifically relevant to the field of your work or the field of your association. So do not shy away from that. And I will take over the responsibility of making sure that everyone talks. So do not refrain from participating. Okay, are you ready? So first question is, I mean, it's a very not easy, I would say it's a difficult question, very interesting. So in a recent paper, it was shown how massive is the carbon footprint of training machine learning models. Training a large model like the OpenAI GPT emits as much as CO2 as few cars during their entire lifetime. Since models are growing and more companies daily train them, how the benefit of a better AI can be reconciled with a massive carbon footprint? This is a huge question, and it's a very important one. It also was, similar one was raised also in the previous keynote talk with Priya. And I would like to open the floor if anyone wants to dare reply to this. Especially, you can always put it in relation to the work of your association, but also with your own opinion.
I can try.
Yeah.
I can give it a start, at least open the conversation here. I think this is a really interesting question. I also think that it's funny how the question is worded, because in a recent paper, carbon footprint, large machine learning model, this could apply to probably a host of papers by now. It's certainly just not one. I could think of at least a dozen that fit this description, and this is a good thing for sure. So the awareness that's building around this topic is surely a good thing. So there's a counterintuitive thing about the argument that's made in the question here, which is we're speaking about those very large models, transformer-based, like BERT-based models like GPT-3. And, there a couple of weeks ago, we had Megatron NLG, Turing NLG, that NVIDIA and Microsoft put together. trained, and these are very large models, and there are a couple of others, obviously, very large models, and training them in a single instance, this is a huge and very visible consumption, not just of money, but of energy, obviously. Now, the point of these models is that their strength comes from being reusable and being used as pre-trained models in order to achieve zero-shot, one-shot, few-shot prediction. So the very point of these models is that they need not be retrained that many times. So the cost of training a single one of these very large, so-called foundational models, it's at least that's the name that the Stanford people give to these models as a center by now, the Stanford Center for Research on Foundational Models, I think it's called, right? Which is dedicated just to these very large models, which have these super interesting properties, which come out of, in a kind of unexpected way from their giant size and from obviously the giant data that they're sitting on. And so the argument I want to make is that it looks like it's a huge waste, or at least it's super concerning that we're training these models. Like it looks like a bad thing. But I would argue that actually it's quite the opposite. Having these super powerful foundation models in a pre-trained form is actually saving us a very large amount of power consumption to achieve the same level of performance respective to if we had to train a similar, a medium-sized model, maybe very, very many times. So I would argue that this kind of work on foundation models is actually a step in the right direction for, the sustainability of AI model training. I would be able to make other arguments. Maybe we return to them, but I'll shut up for now and leave the floor to others, maybe.
Okay, nice. Sebastian, I heard your point and thank you for it. I have Victor on the line and then followed by Emanuela. Victor, go ahead.
Right. I completely agree with Sebastian that foundational models are, those kinds of models are, basically they are so large no one can retrain them. So you just use their output. So it's not too bad. And I don't think it's the core of the topic on AI and its carbon footprint. Because there are things that we tend to forget when we say, well, training one of these models is going to emit as much as X, is that there's 1,000 or 10,000 models that are trained in development, hyperparameter explorations, and so on, before you even get to one. And this is something that makes it so that even if your model is not so big, it's gonna be very costly because it's gonna take a lot of time to just try and make this model happen. And then one thing that is also sometimes overlooked is inference. You have those models that are online and which infer all the time and predict things, and depending on who you listen to, this can even be much bigger than train time. It depends on how they are set up, how often they infer, and so on. And so I think one of the big problems that we have right now as a field is that we actually don't have numbers. There is no transversal study that is going to tell you, well, there's this kinds of models out there and they are deployed on those kinds of systems. They consume that kind of energy. They were trained for so much time and they have a lifetime of that much. And like, we currently don't have data. We have people who, for their own model or for a single model, have points of views. And so that's one thing, is that we need to have more data transversally in the field. And the second thing, if there's one thing that can matter and that is kind of easy to fix, is location. This is because the energy grid you're plugged to is going to be have very different carbon impact. Not even talking about offsets and the fact that large cloud providers are carbon neutral, but that's different from not emitting. And so as a practitioner, if you're wondering, like, what can I do? Well, the easiest thing you can do is maybe move your data and your processing to another region of a cloud provider, if you can do so. For example, here in Canada, well, in Quebec, the grid efficiencies, carbon efficiencies, 20 grams of CO2 per kilowatt hours. This is like 40 times lower than some other regions a few hundred kilometers away in the US. So yeah, I'm going to stop here. I agree with Sebastian. There's a lot to say here. But I'm going to let everyone else speak.
Thank you so much, Victor. And I think actually you linked very well to some points being made in the previous presentations, like Emmanuel and Priscilla as well, stating that we need data and we need numbers to measure this impact as well. And with this, I link to Emanuela, who had her hand raised.
Okay, so I think that there is also a sort of a geopolitical point that we should consider. So, for instance, Sebastian mentioned GPT-3, and then, in China, after GPT-3, they developed Wudao that is 10 times bigger, and it consumes, of course, much more. And it's not that it's improving that much the performance. Okay, it can sing besides GPT-3, but still. So my question is, is there a race? Why it was not possible to collaborate on this? Because maybe, this would have been, like Sebastian said, you train it once and then, everybody else can use it. And then also in South Korea, they develop another one. I don't remember the name, but I don't know if this makes sense. So there is also a geopolitical point that should be considered in this in AI. And like it was discussed last week at GPI as well, and probably Priya mentioned it. The other thing that it's interesting related to this is that, for instance, you're all aware that the European Commission released the first draft of the AI regulation. And in the first draft, not the one that was then published, there was, including all the different elements of high-risk AI system, there was also the impact on the environment of this, so the carbon footprint. And then after lots of discussion, it was removed from the proposal that was published, but they're discussing a lot about it in the Commission on AI, the European Commission, and probably they will include it in as one of the features of the high risk of AI system. So I think this is also interesting, again, as a geopolitical consideration. And the last point, and then I give the word, is that I think that probably what should be done also, we should also invest in a way that on AI algorithm or models that use less data. And I don't know, I know that like federated learning, it's something like this. So you don't put all the data in the cloud maybe, and this is also having a lower impact. And the other thing that it's kind of not a new field, but they're investing in this also, explore more synthetic data also. So you need less data, and maybe this could be also field. So really like to think about new way of using fewer data, less data, and that and having a lower impact on the environment.
Thank you, Emanuela, for making this other point instead. I think now we're getting to an interesting balance. I think Cristiano is next, and then I have Hari.
Thank you. Yes, I want just to add a couple of technical things, interesting, my point of view at least, to what Sebastian and Victor and also Manuela just mentioned. From the research point of view, you see, I'm a physicist. I'm perfectly aware of the carbon footprint of deep learning algorithms, but at the same time, from the research point of view, there are a lot of people studying a new efficient way to train this kind of machine. Some of them also inspired by nature, like for instance, pruning. Pruning is a technique to cut somehow some part of these models, this neural network, or distillation is another technique that we use to lighter the model also in inference. And I also think that in the next 10 years, physical principle together with new insight from neuroscience that are studying how our own brain is very efficient from the energy point of view, this kind of principle could be applied in the next few years in our models. So I hope that they will become more and more not only precise, but also energy efficient.
Thank you so much, Cristiano. And then we have Hari, actually. Yes, go ahead, Hari.
Yeah, I hope I'll not stretch the answer too long, but yeah, I do agree with all the speakers that everybody said, but I'll just add one more direction to it. And to do that, maybe I'll just take a step back from AI and environment. So what we propose in climate change AI is machine learning is not a silver bullet. You can't just use machine learning everywhere to come up with solutions that will work all the time, right? And whenever machine learning is being used, it is to be used on the top of other infrastructure development that has to be done first before using machine learning on the top of it to optimize. I'll give an example to make it clear. So in buildings, if you want to optimize the energy use that happens in buildings, like if you want to reduce the energy consumption in buildings, if we don't have proper insulation in the building and we'll just come up with a machine learning algorithm to implement and hope that it will be optimized, it will be able to optimize the temperature in the building and also save energy, it will be a full stop. Like we need to have better insulation in the building at the first step before moving into machine learning. In the same way, I would like to connect that with the question that is being asked. So it's not guaranteed, and it's also not happens by practice that all these big models or the foundational models might work all the time or is needed all the time for your model or the target that you are trying to achieve. So what we suggest is talk to the domain experts and take the help of physics-based methods, as Cristiano mentioned, and try to come up with models that would kind of optimize your system as compared to using really big models that is often not needed for your system. And in case if you feel that this kind of big models are needed for your system, then there might be some motive that these models will bring about enough reduction in savings in energy or reduction in carbon costs that the amount that is needed to run the computational cost associated with it is a small part of the large amount of carbon that is being carbon emissions that is being reduced. So the key is to be cognizant of your needs and to make sure that all the other loose ends have been tied up before using machine learning or artificial intelligence in your applications, and to use it judiciously.
Thank you so much, Hari, for your contribution. Before we move on to the next question, Priscilla, do you want to add anything, or are you good on this point?
Yes, maybe I agree with what most of the presenters have talked about, but maybe just some, well, the 2 points I would like to add on. One is about the data, because at the moment, I think most people are basing this on assumptions, and we may need to know exactly how much carbon is it, because if you're assuming, then that is not a very good place to start. You need to know how much carbon exactly we are emitting, and then you compare, like, what am I trying to solve with this AI, and then compare to like the carbon that is we are emitting using this AI. Which is better? Should I stop using the AI and forego solving the other problem, or is my solution providing better? The outcome is much better than the effects of the emissions that we are currently giving out. And then the other thing I would say is maybe most of these models I think currently are trained in the cloud. So you could try to work with the cloud services providers that are actually aware of this problem and are actually doing something about it. As you know, I think Microsoft and Google are committed to this, and I think Microsoft says they have achieved carbon neutrality, and Google, okay, I'm sorry, I may be mixing up the two, but one is aiming for carbon neutrality by 2030. So it would be nice to work with such people, with such providers. Not that they're the only ones who are actually aware of this, there may be other people.
Yeah. Thank you so much for your contribution as well. So there is another general question. Wait, let me check if there's still a hand up. No, Cristiano has a hand up from before, I think. So we still have a general question from the public, and then we have a couple of specific questions for speakers. And please, AI for People team, do keep on referring the questions to me from GatherTown. So this is another interesting question. The great speed of AI development may make many devices we daily use outdated very soon, requiring to buy new devices to have all the benefits of new technology? How can we be more sustainable and have the benefits of AI without the need of new devices? I guess this is a question that is similar and yet a bit different from the other one. How can we make the devices itself recyclable or sustainable in a way, and not just the model? Does anyone want to start off on this one or wants to reply?
So I might not have a lot of a response to this question, but I would not totally agree that with the development of AI, we will have to give away all the equipments, or we'll have to update it pretty fast. But what I would believe is, given that the systems that are needed actually, for example, like the actual actuators that we use in the applications where we are trying to use AI, as long as those kind of span the requirements that we need, then AI is just a tool to govern them in a particular way. For example, if we have some robots that do some particular job, then we're trying to train the like, maybe let's say the robot is a humanoid which tries to function like a human. Then we're trying to basically teach the robot to when to use what and when to use the things properly, instead of just adding more hardware functionalities or different things to it. We're kind of trying to make the robot think better. So it's basically more of a software update rather than a hardware upgrade all the time. But having said that, I think I would try to point the asker of this question to all the different resources that are existing in this in the field of life cycle impacts and life cycle impact study, where researchers study about the hidden cost, or the cost that is not often added, of the cost that is used for infrastructure, and they have some impact in terms of recycling and the reuse. And also life cycle impact can be a space where there can be more answers, but I'll leave it to other panelists here for maybe more better answer than me.
Oh no, Hari, this is a great answer. Thank you so much for starting off on this question as well. So I think we had Sebastian before, and then we have Victor on the line. Go ahead.
Okay, thanks. Yeah, so I think the question is cogent to the field of AI, because it's very clear, and we've seen it in the last few years, that for consumer devices to have local AI models, especially deep learning models running, and to exhibit sort of ever higher performance, well, we need ever higher local computation power. It's a fact that it is desirable to have models run locally very often for data protection and identity protection reasons. Personally identifiable data, you don't want to have travel through the cloud maybe, and so you want to have it processed locally. And this is a very good reason. It's a kind of like factor that is the reason why there is this need, and for good reasons, to have this ever increasing device performance, and therefore a call for sort of the renewal of hardware to keep up with the need for performance. So it's not something that we can just sweep under the carpet because it's there. And I think that there's so part of the answer, in my opinion, is with software technique, and another part of the answer lies with work on infrastructure and the network. So this kind of thing, renewal of hardware due to the need to accommodate higher performance, this has been an issue ever since computing has been around. And I'm not, speaking specifically of what happened after 2000, but even before, as computation used to be carried out locally more frequently was even more of a problem. And it still is for the reasons I've just said. And so this is not just the case for mobile devices, but it's the case for any computing device. Okay. Answers, I'm saying, might come from the field of software. And by that, I mean things like adaptive computation, distilled models, platform adaptive computation. By that, I mean models that can adapt to the computing performance of the platform that they're running on in order to produce the best performance possible on that platform and sort of degrade gracefully if the platform available is maybe not the top notchest on the market. And this is, making efficient, very small models. This is obviously, all of us know that, but it's a thing not to be overlooked. It's an ongoing research concern in machine learning. And one of the prime reasons to do that well is for the reason that's being mentioned in the question. So it's because we want to be able to use old devices or not to have to renew devices all too often. And we want to make use of devices which have low performance and still make them work well. Second part of the answer, I believe, comes from the infrastructure I was saying. And why is that? Very simply, you need to have ways to displace computation, relocate computation from a local device to, say, the cloud, in order to be able to make use of a less powerful local device and still have the performance that you want. And this is a reason why investments in AI-supported techniques to displace the computation, and in particular, there's one set of techniques that I think are very important, which is the, I will put them globally into the tag of privacy-preserving machine learning techniques. Sort of, for instance, federated learning or instances of homomorphic encryption or machine learning over homomorphic encryption techniques, where we can actually displace the personal data from the device to the cloud, but not in its raw form. So without exposing it and without giving away its privileged characteristics of being personally identifiable. If we solve these issues, and there are a couple of techniques to do that are being worked on, then we will have overcome one of the hurdles, one of the blocking points why we need to perform a local computation. And for that reason, I think that research in these areas is really interesting.
Thank you.
Done with a long answer. Thank you.
For a very tough question. So fair enough. Thank you for your contribution. And we have Victor lined up after you. So Victor, if you want to go ahead.
Thanks, Marta. So I agree with most of what Sebastian just said. I just want to be also put the question, take a little step back, and I'm personally not so techno-optimist as some say. I'm not sure we want all of these features. Some of them are very helpful and actually required for health reasons and so on. I'm also thinking, well, maybe climate change is about making choices, and maybe we don't have to always have more AI, more complicated systems in our pockets. That's just a personal point of view. It has nothing to do with my research, so I'm just a random dude here. One other thing I want to point out as just a citizen is one of the things you can do is support companies like Fairphone. And if you buy products that you can repair, of which you can change parts instead of changing the entire product because it has been glued together, this is probably wishful thinking, but this is probably the most you can do as a consumer. That would be a short answer.
Thank you, Victor. Thank you for bringing up your point of view as well. I think anyone else wants to take or to try a reply on this? Otherwise, I will move on to the next question. Let me check. Oh, Emanuela, go ahead, please.
Yeah, sorry, I missed the first part because my PC crashed, but I heard the last points, and I think that the only thing that I would like to add, and I agree with what has been said, is that one of the important points here is also the standardization. And so I think that if we define very well, I mean, the standardization of all these, of the AI system, but also the technology, then maybe, I mean, we can reuse what we already have, and we don't have to buy the new model of iPhone, or we don't have to buy the new PC or everything. I mean, it's, I mean, every other day for basically. And this also, I think that it has an impact also on, and it, especially for you that you, I mean, your organization, AI for People. So we as human beings, as people, we really need to think, I mean, what we want to, because at the end, I mean, the goal is that do we want to have the ultimate technology, or do we want to have also an impact with our personal behavior on, I mean, on the environment or on climate change and so on. It's, I think that it's also really, I mean, a question of personal responsibility, that we really have to take, I mean, our own responsibilities on this in our daily consumption behavior, basically. It has nothing to do with AI, but I think that it's also, I mean, it is an important point, this.
Definitely. Thank you, Manuel. A very important point, I think. Priscilla, do you want to add anything before we go and we move to the next question?
I think most of the points I would have loved to raise have been mentioned. So maybe just to recap, not all AI models really need you to change the hardware. Like, for instance, if I'm to look at the work we are doing, none of it requires us changing the hardware. It's basically working with the same data that we have. And then also, just in case you need to change the hardware, then you may have to think about reusability of those hardware parts or something like that. Yes. Thank you. I'm sort of failing to find the how to raise my hand. That's why I think yeah.
No worries. I think if you have, you should have either it should be on participants, and you should have a more button, and you should have the possibility over there, I believe. But even if you want, I see your screen. So if you do that, if you raise your hand also physically, I will take that into consideration. I will see it.
Okay.
Thank you for flagging that. So now I have on the line two more specific questions, not more specific, but like aimed at one of the speakers. One is for Victor. I think, Victor, they're asking you the secret ingredients behind your project. So the question from the public is how you generated the images that show climate change in cities.
Right. It's I mean, it's not a secret. I'm actually currently looking for the papers that that we have submitted. That is also on archive, so I can share that. I'm going to share that in the chat, Marta, and maybe you can forward it to Gather Town. So that's okay. So that's how we do it. The gist of it is we split the model in two parts, and then each of them is trained differently. One is supposed to say, well, which parts of an image is supposed to be underwater if there were a 1 meter flood. So that produces a binary mask, like a map of what locations in the input image should be basically painted with water. And then there's another model, which is trained to generate images of water given a mask and some context. And those two models are trained with very different data. The first one, the masker, as we called it, the one that produces the map of which locations to paint water on, is trained using simulated data. So we have created a simulated world using the Unity 3D game engine. And in that virtual world, we can generate pairs of images, like you take a screenshot at a location in a virtual world, like you have a virtual city or suburb or rural area, and you take a screenshot there, then you tell the game engine, well, put water here. Then you take another screenshot, and then you can therefore have a map of where does water go when there's 1 meter of flood at a given location. Then so you train the model using this simulated data, and there are techniques in the field called domain adaptation to transfer that knowledge from a simulated world, from simulated data to real data in real scenes. And the second model is trained with images of floods. So you detect where water is, you mask it out, and then you train the model to reproduce the water that you masked out from the flooded image. that's the gist of it.
Thank you, Victor. And we just forwarded the link to the rest of the people in GatherTown, so they can also check it out over there, I assume, right?
Exactly.
Thank you very much. We have another question for Emanuela. And the question is, can you articulate more on the well-being indicators?
Okay, sure. So the Italian one, that at the moment it's one of, I mean, it's hard to believe it also for me sometimes, but it's one of the most innovative indicator differently from GDP. It's the BES, so it's the Equal and Sustainable Welfare, sorry. And so basically it considers that to evaluate the progress of a society, you cannot evaluate only from the economical point of view, but you also have to consider the social and environmental point of view. And so this indicator, the BES, included 12 different indicators to evaluate the progress of the society from these 3 different dimensions. So it considered the level of instruction, the level of digital services, for instance, the level of digital humanities or the heritage that it's present in the area, or the quality of public services that are provided, the level of pollution, and so on. And it's a mix of indicators, and at the end you have this final indicator, which is called BES, that it considers really, I mean, these 3 different dimensions of progress and development for a society. And it's very well connected also to the SDGs. And this is the Italian one, but there is an entire movement that is called Beyond GDP, and they are developing some new indicator also at international level. So I can write I can put in the chat the Italian one, and hopefully there will be, I think that there is also in English some information, and also some link to the international Beyond GDP ones.
Thank you, Emanuela. Thank you so much. Yeah, it would be great if you share it in the chat so that we can give that back to participants. And I think we have one big question, which is quite big. It could even be the final one. And I think is one inspired most probably from Manuela's talk as well. So how in general AI development can change from an anthropocentric to an environment-centric approach. And here you can use your own opinion, of course, or also if you have anything done by your association about it, you can feel free to also refer back to that. And I would like to add, and should it change from an anthropocentric to an environment-centric, just to add a layer of complexity or challenge. So please, the floor is open to everybody.
Maybe I can start again. So what my thoughts are in this is that yes, traditionally AI has been anthropocentric, and in fact, if you think environment, environment centric, that is also a kind of anthropocentric as well, because humans are part of the environment, and to save environment is to save humans from future disasters that humans might face. So I feel it's a matter of aligning the interest of anthropocentric way and the interest of environment-centric approach. So as I think Victor might have heard a lot from Joshua Bengio, who is his advisor, and I have heard from some of his talks about one of his work that he mentions where it is like, if you have some public project that affects public interests and does some good for the environment, and there is there is a part of the project that does betterment for some entities that are that just want to make some profit. So if you consider them to be anthropocentric and one of the other to be environment centric, so there needs to be some common grounds that are shared by both, and I feel those are the ones that needs to be strengthened to make sure that the starting point is the intersection between anthropocentric and environment centric, and I think that might be the starting point, and that can also lead to finding more common goals between anthropocentric and environment-centric approach. I think, yeah, that would be my 2 cents into this.
Thank you so much, Hari, and thank you for starting off as well. Cristiano is next.
Yes, thanks. My humble opinion, the answer is very simple. I think that a lot of us, especially scientists and engineers working in AI and technology, somehow lost their contact with nature. We stay a lot of time in front of a computer. We are working in our room, in our lab, and we are building technology, but we are very far from nature because you see, we are used to live in front of our computer in our room. So, in my opinion, to develop a more environment-centric technology, not only AI, but in general technology, we somehow return to go back to our contact with nature, be inspired by nature. A lot of secrets are there also for efficiency. And in addition, you see, staying in nature could inspire us, and somehow then we are going to build, I hope, more environmental centric technologies. This is my very humble opinion.
Thank you, Cristiano, for your opinion. And I think Priscilla also has her hand up. I see it. Go ahead.
Thank you, Marta. So mine would be about, we could do this by elevating the smaller models. So not every solution needs like a very, very complex.
We might have a problem with Priscilla's communication. We hope to get her back. Let's see if we get her back. Meanwhile, does anyone else want to add anything to this question? Emanuela, perhaps. Perfect. And when Priscilla comes back, I'm just gonna...
Sure, yes, fine. So well, the point is that I think that in AI, at least in AI system, I mean, like AI for people, what you do is that to understand how you can use AI to improve people's life. And this is also, I mean, the human-centric European vision of AI. And I think that, I mean, what I presented before is that we really need to ask, I mean, at the end, AI is a tool. And so we need to ask how and why can we use it? And so what is very important is the goal also when you use AI technologies. And I mean, to set the goal, not to improve people's life, but to improve, like also Cristiano said, I mean, the life or the well-being of the whole planet Earth. I think that, I mean, it shows also that we are not like the main element, if I can call us element of our environment, but we are just a part of the entire ecosystem. And we really, I mean, need to look at this not in a sort of egocentric way, but really to see that we are just a part of a whole. And this makes more sense to me. And in this way, like Harry was saying before, I mean, you cannot do, even when you use machine learning to improve the energy utilization of a building, you cannot just do that if then the isolation doesn't work. And this is exactly the same thing. So, I mean, have a look at the entire picture, and this is your goal. And then you can look also about to improve people's life or other things. But it's very important to keep always in mind, I mean, which one is our goal in a clear way. And the goal should be, I mean, to improve the health, not the human being only.
Marta, I'm sorry, I sort of dropped off. Can I try to bring my points together?
Yeah, we're happy you're back. Go ahead, no worries.
Sorry. Yeah, so my point was mainly around being aware about the fact that AI has maybe some of these solutions with AI could be impacting your environment, such as, okay, one of the issues that was raised was the carbon emissions. So if you have this awareness at the back of your mind, you're likely to make more informed choices about maybe you may decide to forego something. So like, as I mentioned, you can use the smaller models and elevate the smaller models that take less time to train and they may not require so much data. So yes, solutions around that. So basically having this awareness at the back of your mind is key.
Thank you so much. Yeah, we're happy to have you back. I'm sorry that the connection was lost, but now we heard you perfectly. And Sebastien, I think you're next. Go ahead.
Okay. Yeah, I wanted to make a. So I think the question is really interesting, but I would a bit disagree maybe with the premise, in the sense that I don't think there's this contrast. Maybe it's also what Emanuela was saying in one way. So, and the reason why I'm saying this is because it would probably be wouldn't make much sense from an, I would say, motivation or incentives point of view to try and develop tools, technology that's only environment centric, because then no one would want to use it if it doesn't bring any benefit, or if it doesn't protect, or even if it harms humans. So it's not like we can look away from what's good for humans, for people. After all, this is an AI for people conference, and just think that there's just the environment. So we're part of that environment. It's a global picture that needs to be taken into account, and so it's not like there's this. If we do one thing, then we need not to do the other one. It's not like that. Instead, the way that I would frame the problem maybe is in terms of what in economics you call externalities, which is essentially beyond just the costs and benefits to yourself and to the entities that you're directly interacting with. There's also the outside world, and the way that you're benefiting in your dealings, the way you're interacting with this with the outside world. So externalities are things like you benefiting from maybe having a larger environmental footprint than you should, just because the environment sort of absorbs your CO2 footprint, and so far it's okay. So this is one way in which people abuse this kind of externalities. Another way to, another sort of externality would be you benefit from maybe the goodwill of people, but then you kind of exploit that or abuse that a little bit too much, and you make some profit in an unfair way off that goodwill. Or your activity, your economic activity is actually harmful for society in some way. Or maybe your business model is centered on the exploitation of data sets that contain personal information that's not been released under the consent of the owners of that private information. So this is all the kind of externalities you kind of like, as an economic actor, abusing these externalities and making an unfair use of them. And so I think the role of AI in all this, and especially of, let's say, AI engineering, because the role of, I would say, AI users is perhaps even clearer. The role of AI engineers in all that is to make sure that in the kind of tools we build, we devote attention to ways in which we can accommodate and we can control the impact of our tools on those externalities. So that means, do some work, or take into account, when we design our systems, take into account how the tool, which some believe, in a kind of blind fashion, will be neutral, but instead take into account how these tools will have effects that spill over just the direct intended usage. And so take these externalities into account and maybe build in some ways in which we can reduce or steer some of those in an intended way, so that it's not left to chance how much CO2 that model consumes, but maybe it's controllable. Or maybe it's not left to chance how much personal information this model gives away, but instead it's controllable and might be adapted. So this is the way in which I think we have this role to play to get these things right.
Thank you so much, Sebastien. Very, very insightful. It was very nice to hear all of your thoughts on it. By now, the time is over. We're just 1 minute late. We got carried away, but we're not too late. I'm sorry if I stole a bit of your time. Just quickly, before stopping the live stream and before going away, this is the last activity of the day for the first day of CAIP'21. So I just wanted, now it's my turn to share my screen very quickly to basically show the participants what's up for the second day. So for tomorrow, what to expect? While the thematic, let's say the theme of the day for today was the environment, for tomorrow, the theme is civic participation. So we're going to start with a more academic session from 11 to 1, and this is Central European time. So where part of the authors will present their work. And then we're going to have a session on getting to know AI for people. If you're curious about what we do come along. We're going to talk about one of our main projects about a podcast. And then following, we're going to have the follow-up of the workshop that we had today, an introduction to artificial neural networks for tumor detection by Meheran. Then we're going to have a keynote speaker, Sneha Revanur, who's going to speak about civic participation. She did amazing work in basically stopping the passing of a law on using risk assessment algorithms in the criminal justice system in California. And she's very young and bright. Do come along and listen to her if you're interested. And then we're going to have another roundtable on AI and civic participation and rights. I also welcome these associations here present today. If you're curious, do come along for tomorrow. And we can end the evening of a Sunday while watching together Coded Bias, a very interesting documentary that most of you might already know, but might not have watched. So please do come along if you're curious. We're going to have a little discussion after that. And I will stop sharing my screen with this. I want to thank you all for being here. I will now stop the live stream, and I hope to see you in the next day of the conference.